Hello friends, today we'll learn how to find the determinant of a 3 by 3 matrix. The learning objectives we have is we'll find the determinants by diagonal method, and we'll learn to find the determinant by Cramer's rule. So first let's see how we can find the determinant of a matrix by diagonal method. We are given the matrix, a 3 by 3 matrix. To find the determinant, we have 1, 4, 2 in the first column, 2 minus 2, 5 in the second column, and 3, 3 minus 1 in the third column. So what we'll do is we'll now duplicate the first column and the second column. We'll have something like this. See, when we duplicate the first column and the second column, we can see it that's behind the third column. We'll see 1, 4, and 2 behind 3, 3, and minus 1. After that, we'll see the second column 2, minus 2, and 5. So after duplicating that, we now have to multiply diagonally, that's starting from the first element, the topmost element, that's 1. You see, let's see the direction of the multiplication. We multiply 1 by minus 2 and minus 1. After, we multiply 2, 3, and 2, followed by 3, 4, and 5. Then we now turn again to multiply 2, 4, and minus 1, 1, 3, and 5, 3 minus 2, and 2. Now look at it here. We'll see, first of all, we'll multiply 1 times minus 2 times minus 1 plus 2 times 3 times 2 plus 3 times 4 times 5 minus, go to that's the fifth column, 2 times 4 times minus 1. From the fourth column, 1 times 3 times 5. And from the third column, 3 minus 2 times minus 2 times 2. The columns I'm mentioning is the elements you pick from and then you multiply diagonally. Like if you pick from column, first we pick from column 1, we multiply diagonally. Pick from column 2, we multiply diagonally. Column 3 diagonally, and we then move to column 5 and still do the same. So now we'll resolve each of these brackets. First, the first bracket, we have 1 times minus 2 times minus 1, which will give us 2. Second bracket, 2 times 3 times 2, which will give us 12. And the third bracket, 3 times 4 times 5, which will give us 60, minus, then we go to the fourth bracket. We have 2 times 4 times minus 1, which will give us minus 8, plus 1 times 3 times 5, which will give us 15, and lastly 3 times negative 2 times 2, which will give us minus 12. So 2 plus 12 plus 60 will give us 74, and negative 8 plus 15 minus 12 will give us minus 5. That's negative 5. Now the negative 5, the minus will nullify the negative 5. We'll now have plus 5. and the answer will now be 79. That's the minus will change to plus. That's 74 plus 5 will give us 79. So that's the determinant for this 3 by 3 matrix using the diagonal method. The diagonal aspect here is how we do the multiplication. So let's move on to uh, the next method, which is the Cramer's rule. In the Cramer's rule here, we have actually two approach in Cramer's rule. We can either go by the column or we go by the row. It's either the column or the row. So let's use the column approach first. In the column approach, you see, we'll strike first column and first row. We have 1. Then the elements that are not affected is -2, 3, 5, and -1. So -2 times -1 will give us 2, and 5 times 3 is 15. So 2 minus 15. Then we'll go to the second column. Okay, in the second column, we strike out the first row and second column. So the point of intersection is 2. Just like when we strike out the first column and first row, the point of intersection is 1. So here is 2. So now the elements that are not affected is 1, 4, 4, 3, 2, and -1. So 4 times -1 is -4, minus 2 times 3 is 6. You have to note that inside the brackets, when you multiply the first two elements, then you put the negative sign and then multiply the second two elements, like -4 times -1 will give us 4, minus 3 times 2 will give us 6. So we move to the third column. The third column will strike. The point of intersection is 3. Then the elements that are not affected is 4, -2, 2, and 5. So 4 times 5 we have 20, minus 3, no, -2 times -2 we have -4. You remember that inside the brackets you subtract. So the first bracket will give us -13. That is 2 minus 15 is -13 times 1 is -13. Then the second bracket, -4 minus 6 is equals to -10 times -2 will give us 20. And the -4 will nullify itself and we have 20 plus 4, which is 24, times 3 will give us 72. So if we add up all that, we have our determinant to be 79. That's it for the column approach. So let's go to the row approach. The row approach will still strike first the first row and the first column. Will get 1 bracket open, 2 minus 15 bracket close. You strike the second column, the second row, you have -4 bracket open, -2 minus 15. The -2 is gotten from 2 times -1, we have -2. Then the normal minus that is always inside the bracket is there. Then 5 times 3 is 15. Now we are in the third row. So the point, as you can see, 2. Then the elements are not affected is 2, 3, -2, and 3. Now in this element that are not affected, the first The column 1 is 2 and minus 2. Column 2 is 3 and 3. But how we are multiplying is we multiply the first element in column 1 with the second element in column 2, and then you come back and multiply the second element in column 1 and the first element in column 2. So that's why we have 2 times 3 give us 6 minus that 6, then the normal minus, then minus 2 times 3, the minus 2 in the second element in the first column times 3, that is the first element in the first element in the second column. So we give us minus 6. So we'll resolve the brackets. The first bracket will give us minus 13. The second bracket will give us 68, and the third bracket will give us 24. And if we sum them up, we have 79. So we see that any approach or method you use, both grammar rule or determinant or the diagonal method, you will still get your answer. But the fact or the basic thing here is for you to understand the basics, the approach, what is used, how is being used, so that you won't get confused, because in mathematics, even the signs can alter everything. So we have to note that the element in row 1 column 1 is always positive, and then the element in row 1 column 2 or row 2 column 1 is always negative. As you can see, let's look at the element in row 1 column 2, that's 4. You see that you put negative there before the 4. And if you also check the column approach, you'll see that we'll put that the column approach, when we strike row 1 column 2, the negative sign comes before the 2. You can rewind the video and see that. So, and the element in row 1 column 3 or row 3 column 1 is always positive. So it's a positive, negative, positive stuff in this crammer's rule. That's basically all you need to cram. The first one is positive, the second column or the row is negative, and the third column or third row is positive. And also have to pay attention to the signs, the negative signs inside the bracket, so that you won't misplace or miscalculate the equation or whatever that is given. So that is it for the matrix 3 by 3, the determinant for the matrix 3 by 3. Thank you for watching, and I hope the video helps.